Okay, action for time for today. Can you mute it? Mute the volume. Mute. Come down the volume.
I know you don't.
Okay, we good? Okay. So welcome everyone. I think let's get it started. So today is the first seminar for this year. And today we have Pedrina Santos. And we actually tried to schedule her last semester.
Yeah.
Let's see, it's so busy. So we finally managed time this time around. And she recently joined FSI. But before she was at Arecibo Observatory, a senior scientist there, and also a PI of the Caribbean Climate Open Research, CCORE, facility on the island of Culebra, sorry, Culebra, yeah. And a little background on her, she has a bachelor's degree in electrical engineering and did her master's and PhD from INPE in space geophysics. They study plasma bubbles and dynamics of the ionosphere thermosphere systems. We're really excited today, and let's hear more from her.
Yeah, thank you, Daka, for the
Thank you.
introduction. Thank you all for being here so late to hear some of my background. I prepared this seminar because I know that I think most of you are not from this area. And Daka also said that the students are going to be here. So I try to give more a general overview of what's going on. And so as he said, I have been at Arecibo for the last 17 years, and I started to work with Airglow there in the optical laboratory about like maybe 5 years ago, 6 years ago, I think even more. So I try to give you how we can use Airglow to study the upper atmosphere and show you some results and some plans that we have. So what is Airglow? Airglow is a very faint light that comes from the atmosphere. It comes during all the time, daytime, nighttime, during twilight. And basically it's due to when the sun it's on ionized, to put energy in the atmosphere, it creates the ionosphere, excites the atoms and molecules, and at some point they have to go back to their stage, the base stage. So they release some energy, and that's what we see as this light that comes from the atmosphere. So like 30 to 40% of the total background at a very dark night, when you have no moon, when you have like camping outside, the city lights and everything comes from the Airglow. That's a picture from they took from the International Space Station, where you can see the Airglow layers, the red color there, then it's also the very thin green and the yellow one. So that's how Airglow looks from space. And basically, depending of the height where we're looking in the atmosphere, the composition of the gas that we have there, we have the color that we see the emission. Here's just an example, like the sunlight in the spectrum of the sunlight, and we have, like we saw over there, let's see here, okay. The green line that peaks at 5,577 angstroms, and we have the green line, the red line for 6,300. We have the sodium, that's the yellow color that we saw over there. So it's like the way that we identify the emissions in the spectrum. And here we have, not coordinate, but I'm trying to look here. So here is the atmospheric layers. And we have from the troposphere to the thermosphere, and the yellow part is the part that's ionosphere, that's the ionized atmosphere. And basically you can see here some examples of the Airglow, the green line again, the red line, the UV Airglow. And since it comes from specific regions and depending of the reaction, the composition, it carries, all the Airglow carries information about temperature, composition, density of the atmosphere. So we can use Airglow to study the several parts, layers of the atmosphere, and we can also trace any particular, any oscillation that happens on the atmosphere. So another, just to give you more, we work a lot with the red line and green line. I think people that maybe hear about that, that's the two more user emissions that we have from the oxygen and 6300, 5577. And we also at Arecibo, we only work with night glow emissions because the day glow is mixed with the sunlight. It's very faint, so it's very hard to have equipment to see that from the ground. So the red line, it peaks around 230, 250 kilometers. That's the peak of the ionosphere. And the green line about 95 kilometers. So the mechanism that generates these lights, these glows, they depending of the composition and also from the concentration of the oxygen on the atmosphere. So that's why anything that happens with the Airglow, if there is variation of the Airglow, we know that something is going on the ionosphere, and particular for the 6300 F region, and the green line on the E region, because that's where they are most part of the emission comes from. So we have, like in the Arecibo Observatory, we have basically two types of optical instruments. Ones that they do a spectrometry, that we have a high resolution measure of the intensity of the light spectrum. For example, we had the Fabry-Perot's, we had last, until we closed, had 4 over there. We have one spectrometer, and we also have the instruments that they do low resolution, but they are more concentrated intensity of the Airglow. So in this category goes for the photometers, they are sky imager. So here I put a table. I'm not going to all the instruments, but if one is interesting, we can talk later in other opportunity. I can show you pictures, more specifications and everything. But basically they also differs of the field of view, the time resolution. For example, the outside imager, we can obtain 2D images over a large area. For example, for the 6300, we can see like 500 kilometers diameter from where the imager is. So it's a big area, like over all Puerto Rico and outside, because Puerto Rico is very small. And we can study plasma perturbations on the plasma, we can study tides, we can study waves propagation. The photometer, it has a very, it's a very narrow field of view. So we can change from 2.5, the one in Puerto Rico, to like 5 degrees. And we can see, we can obtain the time intense time series of the intensity of the emission. So we can also study waves. We use that a lot when we had the heating facility in Arecibo Observatory. That was something that excited the atmosphere, generating the artificial plasma. So we could see the very pumping on the photometer because it has a very high resolution. So it was really nice to see the pulse that we saw. And we have the spectrometer. This one, it goes for a range. For example, you select a range of wavelengths that you want to scan, and it goes, and it also gives you, can give you the temperature of the MLT, the medium mesosphere, around the mesosphere. And the Fabry-Perot's that are very high resolution. We actually have 4 in Puerto Rico. 2 was for the green lines and red line, that was a high resolution one. So we can get the temperatures and winds for the neutral atmosphere. And we have 2 others that were more dedicated to see helium on the top side of the atmosphere. And they also have some use for the H-alpha emission, and that we also have in the atmosphere. So just an overview to see the different kinds of instruments that you can see, study Airglow. Okay, And I tried to get a better, but I found just one gold. I think that's maybe 100 knows more than that. And just to give you an example of everything that's gold on, from the lower to the upper atmosphere, we have a whole bunch of wave propagations, gravity waves, tides, planetary waves. There is this region here that's new, like a turbulence and mixing region, the mesopause. And up there there is some of these waves that comes from the lower atmosphere that they propagate to the upper atmosphere, they generate secondary waves. So all of these deposit energy and momentum on the whole picture of the atmosphere. So contributes to all the things that happen. It's not just isolated. And we also have some structures that they go like the plasma bubbles that they form around the field, following the magnetic fields. So it's a very complex system. It's not just like we see some mountains here, you have the air circulation, generate some waves, and that's it. No, it can go up and generate other oscillations and it be very complex. So we use Airglow. Airglow is being used from the ground-based instrumentation, like I showed you, and also from the satellites like GOLD, to study all these things. Some of these things that each instrument or each person is dedicated to certain topic. And so I think that's everything here. So this is an example of one fluctuation that we have in the F region. That's one image of the Airglow in 6300, the red line. So they cause, let's see if we can play here. They are called medium scale ultraviolet atmospheric disturbance, or MSTID. And they are basically just bands that you see that pass there. Turn again. So they happen a lot at mid-latitude, and they come here, like dark and bright, dark and bright. And there is a lot of controversial about their source. Some studies show that they come from the lower atmosphere, the gravity waves, like from tropospheric events or whenever, and they propagate and generate the MSTG, but this theory by itself doesn't not explain all the complexity of the MSTG. There is some other theory that relates to some kind of instability of the nighttime F layer. And there is others that talk about the coupling between two regions and the electromagnetic coupling between these two regions generate the element stages. So we did a study that was in two parts, but we just finalized one. That's the climatology of the element stages in Puerto Rico. That was from 2015 to 2019. And we want to understand if you could get a better information how this and contribute to define what the sources of this phenomenon. And here I put some results. I'm not getting how but one thing that we did a very like, it's not a new, but was not the kind of methodology that the previous studies did. We basically isolate like the seasonal, the solar, and the magnetic dependence. That's most part of this phenomenon. They really respond to the solar activity, geomagnetic activity, and we got some results that were not so, I say that people didn't see before. For example, there was a lot of studies telling that there was no correlation between the increase of the geomagnetic activity in the decrease of MSJGs, and we saw that there is a correlation, but depending of the season. We also saw that the correlation that can go for correlation and non-correlation depending of the season for the solar activity. And we saw this was pretty likely known that there is solar dependence of the rate of occurrence of MSJs. And this behave or it agrees with the previous works that we did about the neutral winds in Puerto Rico. So one thing that came out for this study that was not on the scope of work, that when we start to look at the results, we realized that the occurrence rate of MSJs dropped during the peak of the hurricane season in Puerto Rico. So we went behind some other data from Puerto Rico. That's GPS, is not optical data, but that's from our collaborator, Natasha. She's from Connect in England, and she had some GPS around the island. She also saw that during 2017, that was a year that was a big activity for hurricanes and everything. When it starts the hurricane season, that the occurrence of the MSJs also dropped. So we start to go dig more on these things, and so that comes to Hurricane Maria that hit Puerto Rico in 2020. It's not 2020, it's 2017. Actually, it's the opposite. It's September 20, 2017. So great. So one thing that has the Hurricane Maria was really like he developed really fast from like 2 days was from tropical depression to a major hurricane, and it crossed Puerto Rico and crossed after also Arecibo Observatory. And when we try, we say, okay, we have this, we saw that other thing, maybe we can find something else, but all the equipment we usually shut down during the hurricane, but we realized that we have some Airglow data before the hurricane. And so we look at the photometer data, and here we have the green line and red line, and here is from the other points from the Fabricero. And when we did the average and you took the residual, we realized that there was a drop here for both emissions in both equipment. So it was not, because first you saw, okay, maybe it's just instrumentation or something that's going on. But when so that was in both emissions, said, oops, something is really going on here. So we also saw, I could put the movies here. Usually the MSTIDs, they have a very usual propagation direction that's southwestward in the North Hemisphere. Yes.
I'm sorry, on your last slide, there was the plot on the left, it says local time.
No.
So like it says it goes from 19 to 29, is that
Well, finish midnight and goes again 0, 1, 2, 3, 4, 5.
oh, okay,
Okay,
thank you.
From 7 p.m. to
yeah,
So
sorry.
for
Sometimes I even cannot see what, if I put my glass, I don't see. So, so they usually propagate in this direction, but when was before Maria, they were propagation in the direction that was coming from the source, that was the big tropospheric force. And this was, Maria was about 900 kilometers away from the Arecibo Observatory. So we start to think, really, we are feeling the effects of this source in the upper atmosphere at this large distance. So we put together a project that was approved by NSF. We are in the second year of this grant. That's a collaborative proposal that calls FACTS. That's the forcing of the upper atmosphere for coupling of the troposphere during extreme weather systems. So this is I think that's 50 years or 100 years, now I cannot see here, of hurricane tracks. Puerto Rico is somewhere around here. So even if you don't, you are not hit by hurricane every year, thanks God. But we are close to the path. We are always there. So that's the main idea of this project. Let's take advantage of this location in US, because there is no other place in US with all this equipment, this cluster of equipment, that you can understand better the relationship between these tropospheric events, the biggest one, and the upper atmosphere. So that time, when we proposed this project, we still have the Arecibo Observatory. And I didn't show here because I was talking about Airglow, but we saw the signatures in other equipments also. The VLF, that very low frequency, that's very low, the 60 kilometers about. We saw in ionosonde, that's kind of radar instruments to see the profiles on the upper atmosphere. And so we said, okay, let's use these instruments that add more, because right now we had the two sites here in Culebra and Arecibo for our Airglow image, but let's try to cover more this path over here. Let's put two other VLFs because they can cross out the Atlantic and they see these fronts coming during that path. And so we proposed this project to NSF and was approved. And so Arecibo closes, and we basically move all the equipment to Culebra. And the project's kind of a little bit delayed, but we are on the process. So I put just one preliminary result from some Airglow data from the Fabry-Perot. These are intensity that are measured with in Regis by the Fabry-Perot red line. So we have, that's from 2014 to 2020. All the data that we have, we put that in a function of the universal time, the intensity, and we did also the solar activity, geomagnetic activity, and like to see how they behave with these two forcings. And from the data minus the model, we got a function. And that's all the tracks of these hurricanes that happen during this time. And the red points are the position of the hurricane eye. So therefore for 2014 to 2020. So when you put the latitude in longitudinal dependence of the residual, that's the data minus this model. Luciano works on that. So we use this information to see the variability of the emission related to the position of the eye of the hurricane. So here we have the hurricanes that were during this period, the position of the eye, and the intensity of the 6300. And so we see that's when in Puerto Rico is here. So when the systems are approaching Puerto Rico until a certain time, a certain range, we see a decrease on the intensity of the brightness. So it's really happening. And it's also not when the system is right over Puerto Rico, because that was one discussion that we have with the referees from the proposal, because they said you are proposing to use Airglow data, and Airglow data depends on the weather, because if there is a lot of clouds, the data is not good. And we said, okay, but we have previous results that we saw that doesn't need to be there, but needs to be approached. And so just show us that really that's what's going on. So we are digging into data for the radar, because we have the ISR radar, we have the LF radar. So we are putting all together to understand better what is going on. That's just very preliminary. And we have to stop off just to close out Arecibo. So we are in this process. And another thing that I want to mention to you that we are doing some time, but we want to reinforce now. This study is about the climate change. We all know about climate change. We all know what's going on, but what's going on the bottom also interferes what's going on the top. So once that we have the shrink of the middle atmosphere, the ionosphere also suffer, and the thermosphere, like the dense of the air density reduced, and so we have, it's a chain process. So it goes up to the magnetosphere, ionosphere couple, it affects the satellites, it affects a lot of things. So how we can contribute to that? So the only way that we can, only way no, but one very reliable way to do is have long-term data sets, because we cannot do climate change studies if you have like no isolating the effects of other forces like solar force, geomagnetic force. So we really need to have some range of the data to see that. And that's why we're really like not letting go Arecibo for the optical and SAS department, because it was running since 1963 and it is one of the most extensive data from aeronomy that we have. So that's why we, with UCF and Julie, we moved whenever we could move to Culebra to continue with the algaes, because it's really close, like 150 kilometers away. So algaes database from the photometers, Fabriperos, spectrometers, and everything, and also some radio VLF, we have GPS. So we continue it. That's a difference on location, but not a big difference. So the database will continue. So I just put an example that one study that we did using Fabripero data and ISR data at Arecibo Observatory, that we saw that the altitude of the peak of the F region of the ionosphere was coming down like the rate of 700 meters per year. That was from 30 years of data. And so we also did this in 2012 or 2011, when you saw also the neutral winds, how the neutral is the meridional and zonal components of the neutral winds were.
Of the what?
So yeah, but so now Sean and I are working on putting more data here to
Of the neutral winds?
neutral winds.
Okay.
Yeah, but they have two components, zonal and meridional.
Mhm.
So so we are putting the data to from 2020 to, that was 30 years of data, and we are adding up to 2020 something, 22 now, and we can see that there is a trend in both components that are not due to solar, seasonal, or geomagnetic activity. So this work is in process. We don't know what really still working on that, but we know that something is going on and we need to contribute to that. So that's where, like, coming back to CCORE, because so once that it was established 2015, and the idea was to have more Airglow statistics, more data available to simultaneous data with the radio instruments that we have at Arecibo. We start with one container and one sky imager. And in 2018, when UCF came to the picture, we moved it to a better location. We adding instruments, we add collaborators. In 2023, was in January, February, we also add meteor radar there, and we have more collaborators, we have more instruments. Then this number is up already here. And so we are at the instruments, the data from the support 6 different proposals. So I led, and other was from users that we are using the data. And so we are looking forward now to, once that we start this facility with the name was remote optical facility, because it was only on sky image and one, nothing more. And now we change, we put Caribbean Climate Open Research and Education Center, because we want to grow, we want to have more collaborators. This is what the facility looks like. We have now 2 areas in Culebra. So that's Puerto Rico. Culebra is right here. It's a very small island. 70% of the island is a natural reserve. So there is no light contamination. There is no R5 contamination also for radar. So that's very ideal conditions. So this is where we have all the optical facilities. We also have lodging there. And that's where the meteorite is placed. It's like 5 minutes from one to another site. We have to do this because the radar required a flat land, and here was on the coast, so not so flat. So this is what we have right now in terms of observational capability in Culebra. This is all the optical. We have aerosol LiDAR that was just placed there by Jens. It's not operating right now because he's still looking for, see where he's going. He didn't join FSI. So we have Airglow images, we have aviperos, photometers, spectrometers. We also have the meteor radar, GPSs, what's that? Geometer, VLF, HF receivers, and we have lightning sensor. And we also have a ionoson that's not installed yet, but we are moving from the pick up the parts in Arecibo to mount in Culebra. So Julie, you came for the lecture slides. So this is what we are trying, we have right now in Culebra, and also PK Mano I think is planning to put his Callisto over there. So we have solar, what we planning to have meteors, atmospheric education outreach, climate, and I left this white because whenever you guys, I don't know, have any ideas, want to collaborate, we are here. I think that's it.
Okay, let's give a couple of seconds for the speaker to breathe, and I think we're ready for the questions too. Any questions from online participants?
Sure.
Sorry if I missed it at some point, but how much downtime do you experience before and after? You said, because you don't take measurement when the hurricane's directly over you, so how?
Well, it depends of the instruments. The ionosonde was on.
Oh,
We didn't, it was only an antenna. We even didn't know that was on. We just realized when we got the data. And the data shows a lot of nice things, wavy propagation. Also, I didn't show because was focused on Airglow. But the optical instruments, when it was in Arecibo, 2 days, we take it out because so the clouds also start to, well, the night before the hurricanes usually is very like calm. And so you can feel that something's coming. But the radar was more like maybe 4 or maybe some, like some couple of days, was not that. But to come back after Maria, like 15 days after Maria, the optical instruments, everything was on. But the team was,
again at CCORE soon, most likely.
huh?
There's a hurricane coming.
Yeah, so but it's not going to Puerto Rico. We are okay.
So
For this, yeah. But so we also have our technicians over there. So if something happens, they already went there last week, so they put shutters everywhere. If something comes, they needs to take it out, the cameras and put in place that.
So do you unmount the meteorite radar for a hurricane?
No, the meteorite, we are not going to come out.
Very
It's-
well.
Yeah, it's secure. I don't think that, maybe the container we fly, no, it's not,
Nah,
it's
container,
hanging out from there. No, the meteorite, I think it's the less concern. It's only antennas there.
Mhm.
I don't expect. But there was a container in Culebra during Maria. So we shut up, that was the time that was only 2 instruments. Was one sky imager, one high frequency receiver. So the receiver was there, nothing happens, and the container was okay. I also just lose one cable that was like twist, but no, survived it. This location, the wind hits stronger, but we are prepared, but we never know.
So you're looking at a lot of the fluctuations or for that
emission line, that one oxygen emission line, I think it was at 6,300 angstroms.
Mhm.
And you looked at it before and after, like. A potential hurricane came through, what was the name of the hurricane again?
Maria,
Maria, after
Yes.
Maria, so you saw,
oh, yeah,
unless
that,
I misunderstood.
yeah, that is because when we have no system comes. We know that the MSJGs, the north hemisphere, they always travel in one direction, that's southwestward.
Hmm,
It's the normal.
okay,
But when was before Maria, they were going like Maria was here and they were like geez,
Hmm.
like coming from the source. So they were in the opposite what they are normal, considered normal.
oh,
So
okay,
that's what I showed over there. And also we have other emissions I didn't mention, but there was two other emissions, I think was 5577 was like. That were also going, all the fluctuations are coming. From the source.
interesting.
Super
And
interesting.
some of those emissions came from different parts of the atmosphere, because you showed that. different
Yeah,
parts-
yeah, and that's not that they come directly.
Mhm.
Maybe they go up and so they travel because they need to get at a certain angle to be able to propagate when they reach the upper atmosphere. So it's a very complex process. But it's very cool. It's just
May I add something, Pedrina?
yes, going.
There are
Yeah,
other
it's like,
that are typically impacted but hardly. You know of any other place where they are doing similar studies, like in the Pacific or in Japan or Hawaii?
Yeah, they have in the Pacific, they have a chain of, that was one of my conversations that I have with the program manager from NSF when he told me that the optical data was not good to study hurricanes. I said, but they, look, they have, actually it's in China. In China, they have this network of all sky imagers that they use it to do the typhoons, that's the
Mhm.
hurricane. And so he said, well, but that was the referee, was not me. I said, well, but that's going on. So, and they also use the satellites. Gold was very into to that. Also, and ICON, actually, they look for us once before the Maria, the telescope fell, because they want to use data from the radar to do campaigns when they like to do a camp to let everything set when there is a system formed. So we turning on the radar, turning on all the opticals, and the golden icon was going to pass that and trying to see, but so the telescopes now, so it didn't happen.
I was asking because you have a very diverse set of instrumentation at the level of, how is it called now?
CCORE.
CCORE. And all of them together are more powerful to study this kind of, or maybe not all of them, but at least a set of them together are more powerful to study this kind of events. So I was thinking if this is something that when you present at international meetings, you can kind of not sell monetarily, but maybe others can follow your path to build up a similar set to study the similar events at another place.
That's what we're trying to say, because in US, we have like a mango that's a pure of, but they usually have aviperos and our sky imager. They see the storms, the propagation of the waves. That is Asti and Elizabeth. I think they were sometime here, right? Yeah. So they have this project, but they are not in that region. We are the only ones that are there. So that's why we're trying to sell this, but not only for this, but right now it's not only for hurricanes, but it's hard to see like a place where you have the Culebra is small, we are starting now, but like meteor radars also in this meteor radars is more for atmospheric studies, but there is not so many places also that have the meteor radars and optical and GPS and other things in US. They have like ALO in Chile that have all of these, but here in the US, there is
In Canada too, there's a meteorite radar. There's one in Canada.
see. And yes. Yeah, that's.
Would there be a preferred secondary location, like if you wanted to put a second site do you think it should be along the same latitude line, or do you think it would be advantageous to be higher up or cover
For
different?
facts, we want to cover the path of the hurricanes on that launch. So that's why you're adding the VLFs, because the VLF, they have a receiver
Mhm.
transmitting in Puerto Rico and they receive in Brazil, like.
And that was my next
Yeah.
question. So would you want,
Yeah.
instead of latitude,
But It's
longitude?
depending, because when we put the facts project, we also want to use both sides, because when you have both sides, we have a 3D
Mhm.
with our sky image. Now we don't have. So, but also we are interested in both things. So in the future, I want CCORE having another spot in Puerto Rico. I don't know if it's near Arecibo Observatory, that's not there anymore, but maybe in the west side of the island, because so we have GPS from Fabiano Rodrigues, that's the central, a special kind of GPS that studies irregularities on the plasma. And they have in Culebra and they had in Arecibo. So you can see when the irregularity reach Culebra, reach Arecibo, and you can see also the MS changes on the our sky images. So that's something that we want to do, but I don't know.
But these in islands, they are small islands from the water like Culebra.
Yeah,
And
but
they are
so
even
that's,
more places.
yeah, we thought also about that, but the logistics, let's try to get it up. And so we can go around.
Okay, we have one question from Anis from online. Could you please unmute yourself?
Hey, Pedrina, nice talk. My question is more technical. You in one of the
Oh,
slides you
you're
said
muted, Pedrina, unmute your computer.
I need to, okay, sorry.
Somebody
No, we
needs.
should get a sound here.
Yeah.
Then no.
He's muted again.
I don't think that's what they do. You can write on the chat.
Okay,
Can you hear me?
Doctor, if you're controlling the Zoom, make sure your speaker is set to the owl.
yeah, it's connected to the owl is up. So we should
Yeah, but
actually,
is your
yeah,
Zoom registering that as the speaker, or is it trying to use your computer?
Okay,
No,
then
it's
it's
a-
Cristiano.
yeah, it should use owl, it's
Yeah,
already,
first row.
it's already using the camera. Yeah,
The whole session.
so Anis is
hear
actually
me?
unmuted, but we cannot hear you if you're speaking. Let's see what-
I don't think they can hear people online. Can you hear me?
Okay, Stella was
I
up.
can hear you.
Okay,
Stella.
no.
Okay, so for some reasons you can hear me, but you can't hear Anish.
No, I can.
Okay,
I will-
so yeah, I don't know. Anish, they can't hear you. Maybe you wanna write the question in the chat.
Maybe they can hear me now. Can you hear me now?
I
don't
can,
think-
Anis, Christian.
Yeah. So it's something weird with him because okay, for some reason we all people online can hear Anish, but you inside can't hear Anish.
Okay, can you also unmute yourself? I'll just move.
He put the question in the chat.
Just unmute it here. Now do the speaker on. Make it louder.
Hello,
That should be good.
can you listen me?
I can hear you, but
Okay. What do you
No, we
mean?
can hear you too. Now, did you ask the question?
Yeah, he asked if I get the temperature and he's asking about the turbulence. Which turbulence you mean?
in the atmosphere there will be turbulence, right? So the line width will have a contribution from the turbulence and as well as the kinetic temperature. So how do you remove the turbulence part? I was wondering.
That's for the Fabry-Perot, you mean?
Yeah, you use the Fabry-Perot for your
Yeah, that's
for-
we have a software that do that was developed by CPI. I have to go to that part to see what's all the process that they, and actually we are actually talking to Connor now to move the software to us so we can go in out that details.
Okay,
Cristiano,
thanks.
you are welcome, Anish.
Can you hear me there?
Yes.
No, I would only complement something. They were talking about more CCORE, this kind of stuff. Besides this work that Pedrina just showed there, that was mostly related to big events and tropospheric events. Also, we are interested in lightning interaction of the atmosphere too. In the region that we have more things like that is close to the Aguadilla Airport. And about 1.5 years ago, we submitted a proposal to airport because there were the former Rain Solar Observatory. So we are running, there would be then 400 acres of flat land. Then the idea is to put one more CCORE there.
Is that the project with Brad Isha?
I think so.
Yeah, exactly. I have showed this to you, right, Luisa?
Yeah.
Okay, any more questions from here? All right, I think,
So good. Thank you all. Thank you.
good time.
Thank you all.
I have one announcement. It's usually, worse. It's usually every other Wednesday.
Yeah.
But because we missed it last week, so we postponed it today from last week, but we have another in next week. And then from there, we'll go from every other Wednesdays.
We just need to be on the list, the new ones.
So, because of that situation, it's not confirmed until the speaker is confirmed. So I don't want to publicize all the dates. Sometimes we may need to change a little bit, tweak a little bit. I don't want to fix all the dates.
But you plan for every other Wednesday.
Yes.
Okay.
So there will be next one next week, and after that, every other Wednesday.
If all goes well.
Hi, Joey.
All right, thank you, everyone.
Okay, thank you.
No, it's not coming out.
Thank you.
Thank you.